Hello guys, so this is Dr. SHAH FAHAD on your screen. I hope you're doing well. Okay, so today we are going to do IB physics. Okay, let me share the screen with you. I hope the screen is visible. Let me just quickly check. Yeah, it is visible. Okay, fine. So the topic of discussion today is current and circuits. Okay, we have this in our IB syllabus of 2025. So let's do this. Okay, there are three guiding questions over here. How do charged particles flow through materials? How are electrical properties of materials quantified? And what are the consequences of resistance in conductors? We'll answer all three of these questions towards the end of the lesson. Okay? Our main focus will be on the SL syllabus. Okay? So let's get started. Of the IBDP. Okay, IB diploma. Let's begin. All right. So first of all, you need to know what a cell is. I'm pretty sure at this level, you know what a cell is, right? Cell is the device in which electricity is generated. But you must know for a fact that cells provide a source of energy, source of electrical energy for the current to flow, right? That source of electrical energy, which allows the current to flow, is called EMF. So it provides a source of EMF, electromotive force. EMF stands for electromotive force. Although, as I've mentioned this, well, this is my first lecture with you guys, but I repeatedly tell my students that even though the name has the term force in it, it's not actually a force. It's actually voltage. Okay, this is electromotive force is the voltage which is produced in the battery. Okay, in the battery or in the cell. I hope you know the difference between the cell and a battery. A collection of cells is a battery. Okay, now these cells can be of two types. We have chemical cells in our syllabus, and we've got solar cells in our syllabus. Okay, most of our discussion will be around chemical cells. Now let's see what chemical cells actually are. So we don't need to go in the depth of chemical cell structure because that's part of chemistry. We are doing physics here. But just for your understanding, I'll tell you that chemical cells have potential energy which is stored in the form of chemicals. Okay, which is stored in chemicals. So we call this energy chemical potential energy. Chemical potential energy. Okay, now this chemical potential energy is stored in the cell. Okay, so when a current flows through the cell, symbol to represent a cell, big line and a small line. Okay, a big line represents the positive terminal, the small line represents the negative terminal. So when current flows through the cell or a charge flows through the cell, what happens? Energy conversions take place. Okay, the chemical potential energy which is stored inside the cell, chemical potential energy, converts into electrical potential energy. Okay, converts into electrical potential energy for every charge that passes through the battery. Okay, hence we say that this work which the battery does, work done by the battery, work done, what form of work done? Conversion of chemical to electrical. This form of work done by the cell per unit charge as the charge moves through the terminals of the battery is called EMF. Okay, so hence you should know from now on that EMF is actually the work done per unit charge, but remember for the fact that this work done is conversion from non-electrical form to electrical. Okay, as the charge moves across the terminals of the battery. And this EMF can also be thought of as the work which the battery does, meaning the energy that the battery provides to the charge, which the charge uses to move around the circuit. Because this battery or the cell, it's a component of the entire circuit, right? So it has to provide the charge enough energy, which can allow the charge to move across the circuit. Right, so this is about chemical cells. In solar cells, solar energy will be converted to electrical energy. Solar to electrical. Okay? Right. Then you should know the basic circuit diagram to represent a circuit. As I said, a battery is a part of the circuit, right? Or a cell is a part of a circuit. So this is a single cell, but if I want to draw a battery, I'll draw more than one cells. Okay, because collection of cells is a battery. So this is a battery that I have. This is the positive terminal. This is the negative terminal. I'll connect the battery's positive terminal to some external component. Let's say a resistor. This is how you represent a resistor. Okay, this is a symbol of a resistor. Maybe you can have more than one resistors as well. It's up to you. You can have some other form of load. Perhaps have an ammeter to measure the current. Maybe have a voltmeter as well. But this is how a circuit diagram looks like. Okay, let's connect a voltmeter as well. Voltmeter is basically a device that measures the potential difference across a component. If it's measured across a component, meaning it measures how much voltage this component is using. And a voltmeter is always connected in parallel to a component, okay, to measure the potential difference of that particular component. However, the ammeter is always connected in series to measure the current. Okay, so this is how a circuit diagram actually is made. You need to use circuit symbols. You need to know what the basic symbols are. A battery, a cell connected through wires. Remember, these are wires, okay? Usually copper wires are used, and wires that connect all the different components in a circuit diagram. Right. Now, this form of a circuit diagram in which the current flows from the positive terminal of the battery, always remember that conventional current flows from the positive terminal towards the negative terminal of the battery. This sort of a circuit diagram in which current flows only in one direction is called a DC circuit. Okay, a circuit in which current flows DC. DC means current that flows in only one direction. Okay, unidirectional flow of current is called DC, direct current. Unidirectional flow. And this current that is flowing over here, or the conventional current which flows from positive to negative, is represented by the symbol I. Now we'll define what current is in the next lecture. That's it for this lecture, guys. Thank you so much.